Day 126, Notes Pre-Calculus. Today I want to revisit some of the vocabulary terms that we missed in section 6.1. Last week we started our trigonometry unit in 6.2. This time around I'd like to go back to 6.1 just for today and discuss some of the vocabulary terms that we're going to use as we move forward in this chapter. First off, it's important to remember that an angle, we'll call it AOB in this case, consists of two rays, R1 and R2, and those two rays share a common vertex at letter O. And so if we look at this figure number 1, we can see that this is a ray here and this is a ray down here. Each of those are distinctly different objects, but since they share the point O in common, that's what forms the angle. And the angle is always the measurement between those two those two rays. So if I were to rotate this ray number 1, rotate it counterclockwise in this case, it would land in line with ray number 2. And that measurement of rotation is the angle measure itself. Now we would call R1 in this case the initial side, and we call R2 the terminal side. So the initial side is where we would start, and if we rotate in this direction towards this R2, that's where we would end. That's why we call it a terminal side. Now interestingly, if the rotation is counterclockwise, then the angle is considered positive, whereas if the rotation is clockwise, then the angle measure is considered a negative angle measure. So here in this case, R1, our initial side, now rotates clockwise towards R2, our terminal side. This would be a negative angle. Now some of you probably copied this whole statement, which is good. For those of you that didn't, please remember that this information can be found on 408, and perhaps some of the most important information is the description of initial side, terminal side, our positive angle measures, and our negative angle measures. Those you absolutely need to know as we move forward. Now it's important to recognize that while we measure angles, there are basically two different ways to do so, either measuring angles in degrees or measuring angles in radians. Degrees measure incremental changes, the 360 degrees that there are per full rotation. So if I had a ray that started here and I could count the incremental distances or differences between that starting ray and the ending ray, this terminal ray here, there are 360 of those spaced evenly around this center point, this vertex here. I could count those or any portion of those to represent the angle measure around from the initial side to the terminal side of the ray. And while the degrees measure the incremental changes, each of these increments in between each angle, the radian is actually a measurement of length around a unit circle, or a circle with a radius of 1. So if I drew a perfect circle here and I knew that its radius was 1 unit long, let me just draw a radius here instead of a couple diameters. So if this radius is equal to 1, then the radian measure would be the length around a portion of this circle. So let's say I had this radian measure here, and that would be connected to these two sides. Rather than counting the incremental changes between the two, I would just measure this length around the unit circle, and that's what radian represents. And in a full circle, in a full rotation, there are what we call 2 pi radians. There are a number of 2 pi radians around a circle, and that comes from our diameter I'm sorry, not our diameter, but our circumference calculation. The circumference of a circle is equal to our pi times the diameter of a circle. Well, in this case, if the radius is 1, then the diameter is equal to 2. So we have pi times 2, or in other words, 2 pi. That's where this number comes from. Now, it's not real important where that number comes from. It's not necessary that you remember that that's where this comes from, but it is important to recognize that for each revolution, at each rotation, we have 2 pi radians and 360 degrees. It's kind of like a measurement of temperature, Fahrenheit and degrees. They both measure the same thing. They measure angles, but they're done so on 2 different scales. So a lot of times it's important for us to convert between degrees and radians. Now if we have our degree measure and we want to turn that into radians, we simply multiply by the number pi divided by 180. If we want to go in the other direction, we could divide by pi over 180, or just as easily we could multiply by its inverse, or multiply by 180 over pi. These are very important calculations. I would begin memorizing these now in case you need to make the conversion between the two. We'll practice 2 right now in the video here. Let's express 60 degrees in radians. Well, if I have the degree measure, the rule is to multiply by pi divided by 180. And for the next one, if I have my measurement in radians, so pi divided by 6 radians, that would be multiplied by 180 over pi. So if we go to the calculator, we can see that for our 60 degrees, 60 times, and I'll create a fraction here, pi. Now the symbol for pi can be found under one of the special keys on the calculator. It's down here near the alphabet. We'll press this key and select the pi option. Pi divided by 180. And 60 times that is equal to pi divided by 3. As we progress, you'll notice that that radians are often measured in terms of pi. So this answer here would be appropriate as a solution, pi divided by 3. What would not be necessarily appropriate is the decimal equivalent. For example, if you returned a result of 1.047, etc., that's probably not as likely because we start to lose accuracy when we have to round this result. If I leave this result as pi over 3, it's extremely accurate, and it's a good display of an accurate angle measurement. Now in this other example, we had to find the pi divided by 6 radians in degrees. So this time we'll multiply by pi over 180. So again, we'll use pi divided by 6. That's our radian measure. That needs to be multiplied by 180 divided by pi. Whoops. Let's get these symbols correct here. I'll just use a division sign here so I don't confuse the calculator. So 180 divided by pi. And press enter. Now that's a bit interesting to me why the calculator has rewritten the calculation this way. Our end result is correct. It is 30 degrees. I'm going to see if I can type this again without getting that extra division bar. So again, this is going to be pi divided by 6. I'm going to put that in its own set of parentheses. Then I'll multiply that by 180 divided by pi. And there we go. Now that's more traditional, the way we would see this, pi over 6 times 180 over pi. And I like showing it this way because you'll notice that when we multiply these two, the 2 pi values will cancel each other out. They factor themselves out here, and then we're left with 180 divided by 6, and 180 divided by 6 is 30. So the pi divided by 6 radians is exactly equal to 30 degrees. Moving forward, let's talk about three vocabulary terms that are also important. We say that an angle is drawn in standard position as long as its vertex is located at the origin of a Cartesian coordinate grid and its initial side is on the positive x-axis. So for example, if I had an angle just drawn in space, let's say I have an angle shown here, that doesn't mean a whole lot to us. It's kind of hard to interpret. However, if I turn that angle so that it fits on a coordinate grid, let's say that this is the x and y axis, if I turn this so that the initial side, we'll call this one the initial side, is on the x-axis, and the positive x-axis, then the terminal side would be somewhere up here in this case. It's floating out here in space. This is what we would call standard position because the vertex of our angle is located right here at the origin of the graph. So our terminal side, as I said, is the angle, or would be the side of the angle that's not on the x-axis. And by defining this standard position, that gives us the opportunity to measure angles that are not acute. Or in fact, it gives us the opportunity to measure angles that are greater than 180 degrees. Because I guess I could have drawn an obtuse angle this way, and we would have understood the angle to be positioned here. But now we can measure angles that are bigger than 180 degrees. For example, if I leave the terminal side of this angle here, I'm sorry, the initial side of the angle on the x-axis, the terminal side can be moved over here. And rather than being forced to imagine the angle between these two sides in this direction, I could interpret the angle as the measurement around the side here. Or more importantly, let's suppose rather than rotating this far, I rotate the angle one more time, and now I have more than one revolution of our angle. Even though the terminal side ended up in the same position, I might be trying to discuss the behavior of a graph or the behavior of an object that rotates more than once. This position where the new angle ended up, even though it's the same as the first terminal side, is what we would call the coterminal side. Two sides of an angle are coterminal if their sides coincide with one another. So for example, an additional rotation, as I've shown here, or maybe if we investigated an initial rotation that had more than one turn, a coterminal side could have been the same position with less than one full turn. So what I'd like to do to finish out the video is switch over to this Geogebra file. This is an interactive file that might clarify some of the behavior of these angles as we move forward. Okay, so what I have here is what's called a Geogebra file. That's a program that you can download for free to investigate the behavior of these graphs. Now, I've created what's called a slider here, and in this position I can drag this slider to represent any number between 0 and 360. That's going to show our angle measures in terms of degrees. I'm marking the point B with this red dot here, and this is going to be the point on this circle that coincides with our terminal side. So let me show you what happens here. If I drag this slider to the right, this will represent, okay, it stopped here at 38 degrees. So the angle between our initial side along the positive x-axis and the angle between the terminal side here is measured at 38 degrees, and we can see that down here in this corner. Now I can continue to drag this more and more and more. There's my 139 degrees. I could go beyond that if I wanted to as well and continue measuring this angle. Now it's getting a little bit hard to read on this small screen, but that says 251. The measurement from the positive x-axis around this circle to this point B is a measurement of 251 degrees. And this slider stops at 360, so it'll take us all the way there, but you'll notice once I get to 360 degrees, the angle disappears. This 360 degree angle is coterminal with 0 degrees. They fall in the exact same position. Now if I were to continue up to 30 degrees, let's see if I can get that close here to 30 degrees. There we go. 30 degrees is 30 beyond the 360. So if I had spun all the way around once and then continued going another 30 degrees, that would have been a 390 degree rotation. 390 degrees is what we call coterminal with 30 degrees. Now the reason why I created this file, not just to show you that, is because it does a pretty good job of illustrating the differences between degrees and radians. So I'm going to repeat this movement again, but I've just turned on the tracing feature. So anywhere that this B value has moved to, anywhere that that point's moved to, is going to stay on the screen, and you're going to see a trail of red. And anywhere that the ray, our terminal side, moved to, you'll see a black line where it was. So as I start dragging this to the right, oops, it kind of jumped a little bit there. Let's go back and fill in those spaces. There we go. All of these rays, these black rays that are left behind, represent our difference in degrees. So here's a degree, and there's a degree, and so on and so forth. It's very, very hard to measure those degrees in this tiny space down here, and the distances between those degrees as we move to the right tends to get a little bit larger and larger. And in some instances, that just wouldn't be appropriate to measure the position between two rays. And instead, we would opt for this red line here. Now, it is a curved line, but we can measure the length of that curved line by calculating a portion of a circle's circumference. And so that's the difference between your ray and degree. The degree, again, are the incremental changes as we move around the circle here, as we increase the size of our angle, whereas the measurement of a radian is the length of this curved red line. And we can continue to move past 180 degrees, or 1 pi radians. We can move forward, keep moving forward to the end of the circle here. And by the time we get to this point here, you'll see all 360 degrees that go around the circle, as well as the length of that circle being 2 pi radians. So I hope that clarifies the differences between the two in case you weren't exactly sure what they were. And you can think about this illustration as you make the decision to which unit would be appropriate for your calculations in problems in the future.